All right, so a little bit different than the last time we were on here. Um, I'm going to, I've enabled a waiting room feature on here to make sure other people don't join that aren't supposed to join. So when you log in, you're going to see a message saying that the host will let you in shortly. Again, if you get that, say that you like join a meeting late and you get that message and I don't like let you join right away, send me a message through Mind or something else so that, again, I know that you're there waiting. Because if I'm in the middle of teaching, I might not notice that you were there right away. All right. So a couple things here for today. We're going to do this a little bit different. I'm using PowerPoint slides. You probably saw the PowerPoint slides if you had gone to the OneDrive documents for today. Again, I'm going to keep posting that OneDrive folder, as well as I'll keep posting things on Edsby as well. So I posted the slides to the assignment for the notes. If you didn't print out the slides ahead of time, that's fine. Now, there is going to be an assignment that you have to turn in the notes. So just make sure that you're taking some notes. You don't have to take all the notes. Also, since I'm doing it through the slides, again, there'll be some things that are straight from the book. Again, you don't have to copy the entire diagram, the entire picture. Again, copy what you think is necessary. I would make sure that you probably copy the examples and important vocab and things like that. All right. So let's go ahead and go to the next slide here, which is actually the calendar. I had told you guys that I was going to be adding a calendar to our folder. I haven't posted it on Edsby yet. I'm still adding a few things in, but we're starting to get a feel for the pacing as far as like what we're going to want to cover. So right now in the calendar, this is the first 3 weeks of what I'm planning on doing. So currently, I believe that the 10th of April will still be a no school day. I'm really not sure. They haven't said anything about it just yet, but I'm assuming it's a no student day or no school since there's since that's the day that was originally on the calendar that way. But essentially, again, on these days where I'm doing a class, we're going to go over pretty much notes and things like that. Tuesdays and Thursdays are where you guys can ask questions about things. At the end, I'll open it up to some questions as well. But again, today we're going to be talking about lines tangent to a circle. So you can see that we have 5 sections to this overall. At the end of the 3 weeks, we'll do a test. Now, we are going to be changing the way that we scale our grades. So it won't be the same weighting that I had before. So I think it was like 60% was tests. We're not going to leave it at 60%. It's probably going to go down to like 30% for tests. I'll talk about that more as we move on. Yeah, so the question there, the conference day thing, that's not a conference day for you guys. What that means is that on that 10th, there was no students and it's no school because of the conference night that teachers worked. So again, that's a note to myself about conference night on the original calendar. But anyway, I'll be posting more on the calendar as well as like what the different assignments were for each day. So that it'll be an ongoing calendar. I just wanted to get a feel for what we were doing first. Okay, so today, again, we're going over 10-2, which is lines tangent to a circle. Now, again, like I said, you don't have to copy down this entire slide, all right? There's a lot of information on here, and not all of it is going to be things that you're probably going to want to have copied down. Now, I'm trying to view this the way that you guys view it as well, and when I'm looking at it, it looks like the bottom of the slide is getting cut off. Do you guys see the line that's underneath where it says "so" at the very bottom? Somebody tell me if you can't see it. So like that last line, you can see it? Okay. So maybe it's just the way I have my other computer set up. All right. Anyway, so a tangent. We started talking about a tangent a little bit it right before we went on break because I had showed you guys the construction for making a tangent to a circle. But a tangent is a line in a plane of a circle that intersects a circle in exactly one point. So on that diagram, you have M, this line down here, this line down here. This is our tangent line because it's intersecting the circle only once at what's called the point of tangency, and that point of tangency is X. Now, there's a lot of other good information there. We talked a little bit about how the radius relates. So that's what this first idea is hinting at, is how does the actual radius and the tangent line relate to one another? Does anybody remember what that was? You can type it in chat. You can unmute yourself and say it. How did the tangent and the radius relate to one another? I would copy the definition for tangent. Nobody remembers from before break? So again, the tangent and the radius, they're going to be perpendicular to each other. All right. So the main idea here, all right, is that they're going to be perpendicular. So anytime you have a tangent and then a radius drawn to that point of tangency, they will always be perpendicular to one another. So this is an important idea right here. This is theorem 10-1, or it's the theorem for a tangent of a circle. A tangent and the radius are always going to be perpendicular to one another. And like I said, you don't have to copy everything down. All right. Again, these notes are posted as well, so you can always go back and get more later. But again, the important theorem there is that if you have a tangent to a circle, then that tangent is going to be perpendicular to the radius drawn to the point of tangency. The converse is also true. If you know that you have a line that is perpendicular at a point where the radius is meeting it, then that line must be a tangent. Where are the notes posted? They're posted in a couple different places. They're posted on Edsby, attached to the assignment called notes. They're also posted in the OneDrive folder. So if you click on the link to the OneDrive folder, you'll see that all in there as well. Okay, I'll move on. So here's the first example. Now, this example, I would highly recommend copying down the examples as we go. So the first one, we're looking at it says, is segment KJ tangent to to circle P at point J? So in order to figure that out, all right, if you're looking at that diagram, what has to be true in order for that line to be a tangent? Well, and again, this is when you guys can unmute yourself. You can call things out if you think you know the answer, or if you want to write it in chat, you can. What has to be true about that line KJ and PJ? Anybody know? They'd have to be perpendicular. Yeah, so that's what we have to prove in order to see. That's what we have to prove in order to see that this is going to be a tangent. So we need to know that this angle here is a right angle. If this angle isn't a right angle, then it's not going to be a tangent line. So we're going to have to use the numbers on here to prove that we have a right angle. Well, we have 3 lines for a reason. We're trying to prove basically that this is a right triangle. So if we use Pythagorean theorem, c squared equals a squared plus b squared, then we're going to have this entire line from 4 and 6 together is going to be one side. That's going to be our hypotenuse. So that's our c value. So 10 squared equals a, again, doesn't matter which one of the 2 legs we use as a, so 6 squared plus the other side would be 10 squared. 10 squared is 100, 6 squared is 36, 9 squared is 81. Well, if we add those 2 up, that gives us 117, not 100, so they don't work. So is it tangent? No. So that is not a right angle, therefore it is not tangent. Yep. Again, some of you may have noticed if you have your textbook at home, I gave you the book to keep at home. Some of these examples, again, if it's the example and not a try it, it is from your textbook. So if you want to have your textbook out while we do these, again, you can have your textbook and you can follow along with that as well. Now, for the second one, so segment ST is tangent to circle R. What is the radius of circle R? Well, again, if that is a tangent, that means that they have to be perpendicular, the radius and the tangent line. Therefore, that must be a right angle. And they already drew the right angle in there for us this time. So now we can go ahead and set up, again, Pythagorean theorem in order to solve. So if we say, again, c squared equals a squared plus b squared. Now, what is our a and our b value? Well, our a and b, that part's the easier two. We have x and we have 24. So we can go ahead and fill in that side of it. We have x could be a and 24 could be b. C, on the other hand, though, is a little bit harder. We have x and 18. So we're going to have to add that. Now, that makes this problem a little bit more challenging because we actually end up with a quadratic. All right. Now, it's not a horrible problem because some of this will end up canceling out, but we do have to remember a little bit of algebra because on this side, we'd have to multiply this out. Again, if you're doing x plus 18 squared, that's going to be the x value squared, a middle value of these two multiplied together times 2, and a third value of 18 squared. Now, if you don't remember that pattern from Algebra 1, you could just multiply it out by using FOIL, and that would work as well. So I'm going to show the work for FOIL off to the side here. So we have x plus 18 times x plus 18. So we'd have the x gets distributed to both, the 18 gets distributed to both. So we get x squared, x times 18 is 18x. 18 times x, again, is 18x. And then 18 times 18, who knows their perfect squares? No? 324. All right. Again, this part in the middle, the 18 and 18, is going to give us a total of 36 squared plus 324. So that's this side simplified. Oops, I forgot my 2. All right, now the 24, I don't know that one off the top of my head. Let me grab my calculator. That's 576. I think I might have lagged out there for a second. So that's 576. So now we have the x squared and the x squared on both sides can cancel each other out. Right? So if we subtract off the x squared, again, they cancel off on both sides. So now we have 36x plus 324 equals 576. Sorry, experienced a little bit of lag there. Bring the 324, so that said 324. Subtract that off, 324, subtract it from both sides. So we have 576 minus 324 gives us 252. Again, so I have the 36x. Divide by 36, and x is 7. So that problem was a little bit harder, but we now know x is 7, and x was our radius, so that is our answer. So the radius is 7. All right, the question about textbooks. Yes, textbooks We'll have that information out whenever we know for sure that again, we don't know. Again, they got extended. I'm sure you guys heard that we're out currently until May 1st at least. So again, we'll tackle the textbook return and stuff when that time comes. All right. Were there any other questions I missed? I think that was it. Okay. Let's go to the next one. So now, on the next slide here, it says line M is tangent to circle T at B, and line N is tangent to circle T at point C. What is the value of X? So one of the things you have to recognize here is that shape. If we look at this shape here, that's a quadrilateral. What do all the angles of a quadrilateral have to add up to? Everybody all at once. Come on now. 360. Yeah. All right. So they have to add up to 360. So we have two of the angles already written on. One's X, one's 135. And since these are tangents, what are the angles at B and C? Well, they have to be perpendicular. So each one of those is going to be each one of those is going to be 90 degrees. So I saw somebody was waiting in the waiting room there. So again, we have three of the angles now because each of those are going to be 90. This is going to be 135. So if we add those all up, 135 plus 90 plus 90, that's a total of 315. So we have 360 for the entire thing minus the 315, and that's going to give us 45. So X, the missing angle there, is 45 degrees. All right, on the next one. Now, something else that you can keep in mind, again, they didn't say this they don't actually list this as a property anywhere, but if you have two tangents being like this, since those two angles B and C are right angles, that means that those two always will add up to 180, which means that the other two also always have to add up to 180. They will always be supplements to one another. So they always have to add up to 180. That's another way of doing that problem. All right, on the try it for number 2 there, it says circle N is MP tangent to circle N. Explain. Well, if you look at MP has one angle given to us at P, one angle given to us at N. So in order for it to be a tangent, that last angle would have to be 90 degrees. Well, in a triangle, all the angles have to add up to 180. So we have 180 minus the 58 minus the 33. And if we do 180 and subtract those two values, 58 and 33, it leaves us with 89. So this angle is 89. Is it a tangent? No, because that angle would have to be 90 degrees. Angle NMP is not 90, or not a right angle. For part B, if LK is tangent to, so now it's saying if it is tangent, so it's telling us to assume, all right, sorry, it's telling us to assume, anytime it tells me that my connection isn't stable, I'm going to pause because I'm going to assume that means that I could be lagging. But again, that angle is a right angle, it's saying. So what is Kn? Well, again, this comes back to Pythagorean theorem. So I told you guys when we did Pythagorean theorem, we were going to keep seeing triangles and keep seeing them all year long. And again, we have it here again. So now we already know that this piece is 9. All right. So things that we know, we have a C value that is going to be actually this entire length from K to N. So this whole thing is going to be X plus 8. We have this side, all right, is going to be our B value, let's say. This side could be our A value. So if we plug it in, X plus 8 squared equals 9 squared plus X plus 5, that part's in parentheses, squared. So again, the shortcut to this, if you have a binomial that you're squaring, it's going to be the first number squared. The middle number is going to be the two values that you have multiplied together times 2. So 8 times X times 2 is 16. Again, if you don't remember that shortcut, you can always do the distribute property like what we did earlier. So now we have the last number also needs to be squared. So 8 squared is 64. Then on this side, 9 squared is 81. This piece, again, we're squaring it. So using that same rule again, X squared, and the first term squared. These two multiplied together times 2. So 5 times X times 2 is 10X. 5 squared is 25. So now we have X squared on both sides. So we can go ahead and subtract it from both sides and cancel out. Go ahead and bring our like terms to the same side. So I'm going to go ahead and bring my 10x over to the left side. So I'm going to go ahead and subtract the 10x. So minus 10x from both sides. That gives me 6x over here. And I'm going to go ahead and add the 64 to both sides. So I have 81. I have 25. I have 64 all on that side now, which gives me a total of 170. Divided by 6. And I get X is 28.3. And that would be my final answer. Wait, nope, just kidding. I found X. There's one more step. They want Kn. So we need to plug it back in. So Kn is this entire line, which we said is X plus 8. So add 8 to that. So 28.3 plus 8 lag gives me 36.3. That would be my final answer. All right. So now, one of the examples that they had in your book, they didn't really give you anything to do there. They just wanted to show that in there, if you knew that you had those points, you could draw this. Sorry, Amber Alert went off. Oh, let me go back. You said I did something wrong. Aren't you supposed to subtract 64 from both sides, though? Let's see. Did I make a mistake? Ooh, good catch, Alex. And who else said it? Sasha, Alex, and then a few of you guys said it. All right, thank you guys for catching that. There was a mistake there. Let's go back real quick. Well, that was if I knew how to erase with this pen. Okay. Well, that's one thing I have not learned yet is how to erase with this pen in PowerPoint, because It's not giving me the, there it is. All right, erase. So this should have been minus 64 instead of add 64. Maybe that'll give us a nicer number because that number was not very nice. All right, let's try that again. So we're gonna go back to the pen. So we had 81 plus 25 minus 64 gives us 42. So on this side we have 42, which that's divisible by 6. That's a much nicer number. So that's 7. And if that's 7, playing back into our equation there, 7 plus 8 gives us a total of 15. All right, good catch. All right, any other question there? All right, let's go on to the next one. So now, on this one, they gave you some basic information there, and they wanted to know what's the relationship between y, z, and x, z. Well, essentially in the book, they say that you can prove this. So they already have it all drawn in. They already have the proof there. You can prove that those two triangles are congruent to each other. And since those two triangles are congruent to each other, that means that those two outside, these two tangents here has to be congruent. So there's a theorem. Sorry, I don't know why that went backwards. There's a theorem that says if two segments with a common endpoint exterior to a circle are tangent to a circle, then the segments are congruent. So on that diagram, we could add in congruent marks here and here to say that those two are congruent. So it's telling us that if we knew some of those other measurements, we should be able to find both of those because, again, both of them are going to be the same. Again, I don't think we have to actually do that problem. There's a better example here as to how we're going to use this a little bit more. So on this one, it says, what is the perimeter of ABCD? So notice, there's a bunch of tangent lines. The idea here is A is a common point for this tangent line and this tangent line. So if this piece is 7, this piece too has to be 7. If we come over here to B, at B, we have this little piece is 2. So then this piece over here would have to be congruent, and it's also going to be 2. If this is 3 coming from C here, well, then this line has to be congruent to this line. So those would be the same. That'd also be 3. And then we have a common exterior point at D. So we have this side is 6. So this side and this side would be congruent. So this would also have to be 6. So now, in order to find the perimeter, we just have to add those all up. So we have 7 plus 7 plus 2 plus 2 plus 3 plus 3 plus 6 plus 6. That's a total of 36. Now, you can do that a couple different ways. Again, you can add them all up individually like that. You could also say, since they gave you one of each of these pieces, if you took the original numbers, say the 7, the 2, the 6, and the 3, add those up, you would get 18. Well, then double that because all the other pieces would have to be the same. You'd also get 36. So again, there's more than one way to get that answer. Again, you essentially just add them all up. All right. Let's go to the next slide there. So again, this is just a summary of what a tangent was. Just remember, anytime we have a tangent line intersects a circle at exactly one point. If you have the radius drawn to the point of tangency, then they're going to have to be perpendicular to each other. Again, that is just the main idea there. Yeah, so it started on page, I think, 447 right in the beginning. Currently, this slide is on page 450. All right, so now I want to do a couple other practice problems, and then this is going to wrap it up. So for these practice problems, I just want to run through these real fast, and then I'll let you know what the assignment is. Again, the assignment is already posted as well, but you have tell whether each line or segment is tangent to circle B. So first they ask for MN. Well, again, in order for it to be tangent, it has to be a 90-degree angle at the point N. So they gave us some information. They told us that this angle here is 167. If that angle is 167, then the angle that's next to it, well, these are a linear pair. They are supplementary to each other. They have to add up to 180. So if you subtract 167 from 180, that would leave us with this angle as 13. And then these three have to add up to 180. So if we add those two up to 180, you'd get 180 minus 13 minus 79. Now, just looking at this, is that going to give us 90? No, because it won't end it in 0. Right away, I know it's not going to work. If you want to carry the problem out all the way, that's fine. It'd end up giving you, what, 92 for this piece, which then gives you 88 for the angle. So again, it does not work. The other thing that you could do for this problem, this is an exterior angle. You wouldn't even have to find this angle. You could actually just do the exterior angle minus one of the remote interior angles to get the other remote interior angle. So again, there's more than one property that we've done this year that you could apply to this. But either way, you would end up with 88 degrees for this angle. So since that's 88, this one is not a tangent. So then QP. Well, QP, they didn't give us angle measures. They gave us, yep, I can go back to it at the end. They gave us side lengths. Now, careful with this one because that 3 is only for this outside piece. So this piece is also 4. So the entire thing is 7. So now they gave us values of 4, 7, and the square root of 33. Well, 7 is going to be the one that's our C value. So plug it into Pythagorean theorem. We have 7 squared equals 4 squared plus square root of 33 squared. 7 squared is 49. 4 squared is 16. That squared is just going to cancel out the radical, so that's 33. If we add those together, we do get 49. So 49 is equal to 49. We get a true statement, which means that this is a right triangle. So that is going to be a tangent. All right. Number 7. Can't. Let's see. I can try unmute you and remute you and see if that works. Let me try it. But I don't think that's, you might just have to rejoin. I can try sending you out of the room and bring you back in. Hold on 1 second. Did that work for you? If that didn't work for you, then you might have to just leave and come back. So Ted, the reason why there's a 4 next to the 3 is because the radius here is 4. So this too would also have to be 4. The radius is going to be congruent no matter where the radius is drawn. So that 3 is only for the outside piece. The radius had to be the same as the other radius. So this was also 4, and then we added them together. So then we added them together and we got 7. That's how we got 7 for that one side. Okay, on number 7. So we have segment AC. So they're telling us AC is a tangent to B, or to circle D at point B. Find each value. So we know that these are right angles. They're telling us that it is. So first thing they want us to find is the measure of angle ADB. Well, and these angles have to add up to 180, or the two acute angles of a right triangle have to add up to 90. So I could just say 90 minus 31, which gives us 59. So that's for that angle. Then BC, they gave us this entire thing is 9. The radius is 5, so this radius here is 5 as well. So plug it into Pythagorean theorem to solve for the missing piece. So we have 9 squared equals 5 squared plus x squared. That's 81 equals 25 plus x squared. Subtract off the 25. We have 81 minus 25. That's going to give us 56. This is not going to come out to a whole number. We can square root both sides to get x by itself. Now, we can leave this as an exact value. So we're going to have the square root of 56. And if we're going to simplify square root of 56, let me do that up here, 56. What's a perfect square that goes into 56? Let's see. 4, I think, is the only perfect square that will go into it. So we can change this so it's 4 and 14. So you get 2 radical 14, and that'd be a good final answer. And then on the last one, so let me move this box. I can't see my last one. All right. On the last one here, we have segment FG is tangent to circle K. So we have 2 tangents instead. Find the value of each of those. Well, if we know that both of those are tangents, so these are both right angles, which means that those 2 are a total of 180. The whole thing has to be 360, so subtract those off. These 2 then would have to be 180 as well together. So we can say 180 is equal to 2x plus 3x. So we'd have 180 equals, whoa, something lagged out there. Let me just rewrite that. 180 equals 5x. Divide by 5. Oh, hold on. Try that again. Divide by 5. And sorry, I keep getting messages. All right, so what was the thing? 180 divided by 5 is 36. So that's going to be our final answer for the x value. But the angle they want to know, FGH, FGH is this angle, which is 2x. So we're going to have to actually multiply that by 2. So 36 times 2. So 2 times 36. And will give us 72 for that angle. For FG, well, FG, if this is 17, that also has to be 17. So that's just 17. That is it for all the examples. This is the assignment for tomorrow. So again, for the assignment, I'm only having you guys do the part that is the practice of this page. I've had lots of questions as to where to find this practice. Again, you can either, if you have your textbook at home, use your textbook. If you don't have your textbook at home, then I'm posting this assignment to the actual assignment in EDSB. So if you click on the assignment in EDSB, you should see an attachment. Or if you go to the OneDrive folder, it'll be in that OneDrive folder. Or you can use the digital textbook online in order to do that as well. Once you're done, can you go back to try it number 4? Yeah. So let's see. So you wanted to see this one? Again, for try it number 4, the trick there was all of the sides coming from the same exterior point have to be congruent. So the side that matched up with 7 was also 7. The side that was over there with 2 was also 2. The side that was with 3 was also 3. And the side that was with 6 was also 6. So when you add them all up, it gives you 36. So yeah, notes you submit under that notes category. And then the assignment for tomorrow, you'll submit to the assignment. Now, some of you guys came in late, so I'm going to go back to this calendar real fast just so you guys see it in case you missed it. Just for the next couple weeks, this is the plan. All right, so again, that's it for my time today. I said I was going to go over 45 minutes. If you have more questions and stuff like that, again, Tuesdays and Thursdays, I will be holding office hours. And yes, I will be posting this video. It might take me a few minutes because I have to let it process, and then I have to, once it's done processing, upload it to Edsby, and then I post the link. So it might take a few minutes. I also have another class in 15 minutes after this, so probably won't see it right away. What time are the help sessions? On Tuesdays and Thursdays, I'm doing help sessions from noon to 1:30. Currently, I just got informed that I have another meeting on Thursday, so I might have to adjust those tomorrow. I'm going to leave them alone because that's what I've been saying all week. But I may have to shift the time on Thursday. I just have to look at my calendar again. Any other questions? All right, well then have a good day, and I will be posting this to Edsby with a link to YouTube. Have a good day.